Okay, so in this video I'm going to prove by induction the nth term of a sequence. So we can see that if u1 is 1, then to generate the next term in the sequence, or to generate u2, we do 3 times the previous term, subtract 4. And what we're going to do is we're going to prove that any term in the sequence, so for example if we wanted u100, rather than working our way through u1, u2, u3, we can just jump straight to u100 by doing 2 subtract 3 times 100 to the power 1. So subtract 1. So I'm going to start by working out step 1. And step 1 says what happens when n equals 1. So for n equals 1, I can see here that u1 equals 1. And I can also see that the thing I'm trying to prove, so u1, does that also give me the same answer. So does 2 subtract 3 to the power of 1 take away 1, so n take away 1, n is 1, equals 2 subtract 3 to the power of 0, anything to the power of 0 is 1, 2 subtract 1 is 1. So therefore we know it's true for n equals 1. And now we're going to look at step 2. So step 2, we start by assuming it's true for n equals k. So looking at this thing here that we're trying to prove, right, we say, well, uk equals 2 subtract 3 to the k minus 1. So we're just assuming it's true for any number whatsoever. So this is my assumption. What I want to show is what happens when n equals k plus 1. So we want true for n equals k plus 1. So uk plus 1 equals 2 subtract 3 to the k plus 1 minus 1, which is k. So this, if this is true, then this will be true for n equals k plus 1. So this is my target that I'm going to be aiming to achieve. So what I'm going to do now is, in proof by induction, we try and assume that we're stood on n equals k, and we prove it's true for the next number. So it's a little bit like a ladder. So if we're stood on the kth rung, then can we climb to the next, the k plus 1th rung of that ladder? So what I'm going to do is I'm going to use my assumed result, which is here, and I'm going to go back to the question and I'm going to generate, so remember this thing here I said at the beginning generates the next number in the sequence. So I'm going to use that assumed result and I'm going to substitute it into there. So I can see that uk plus 1 equals 3 times 2 minus 3 to the k minus 1, subtract 4. So that's come from we have used the assumed result to generate the next term. So looking at this, uk plus 1 equals, multiply the bracket, I get 6, subtract 3 times 3 to the k minus 1, subtract 4, which equals the 6 and the 4 will subtract and give me 2, subtract 3 times 3 to the k minus 1, I've got a power of 1 there, I add the powers 1 plus k minus 1 will give me 3 to the k. Which is exactly, looking back, which is exactly what our target is. So what we've done is we've proven that if we are stood somewhere on this ladder, then it's possible to climb to the next rung on the ladder, because this matches the target. So to complete the proof, so step 3, we say if true for n equals k, then true for n equals k plus 1. However, the first thing we did, looking back up here, was we showed it was true for n equals 1. So we know it's true for n equals 1. So that means that I have proven that no matter where I am on the ladder, I can climb to the next rung. However, I also know how to step onto the ladder. So that means because I know how to get onto rung 1, I also know how to get onto rung 2, 3, 4, etc. So you know it's true for n equals 1, therefore true for n equals 2, 3, 4, etc. Thank you very much.